Everybody, it's Mr. Gustin back in the physics classroom. Today, I want to talk about the G family. Not the Gustin family, the G family. I want to talk about Mama G and Baby G. I want to talk about the universal gravitational constant and the gravitational field strength here on Earth. These are two different values, G values, that are found on the back side of your equation sheet in the top two boxes where it says constants and conversion factors. Both of these are useful when we're talking about gravity. One, baby G, is only useful if we're on Earth. And when I say on Earth, I mean somewhere on the surface of Earth. The Earth is very smooth in the grand scheme of things, so we use 9.8 pretty much everywhere on the surface of this planet. As we leave the surface of this planet, though, and we venture out into the vastness of our universe, that's when we switch over and we start using the universal gravitational constant, because no longer are we experiencing this 9.8 meter per second squared acceleration or newtons per kilogram force towards the center of the Earth. I want to talk about where this number comes from. How did we get this? Did Newton just dream this thing up, or where did it come from? And so we're going to start by examining the universal law of gravitation that we derived in class today. Mama G, M1, M2 over R squared. Now, we know that if I guess let's draw a picture of this scenario. We're saying 9.8 is us on the surface of this Earth, okay? Us on the surface of the Earth. This is an example of we want to see what our acceleration is, right? Like we want to know what, if I'm standing on Earth or I'm near Earth's surface, the only force acting on me is the weight force. So I can say that Fg is in fact my net force. Let's say Fg is in fact m times a. Right? My mass times my acceleration while I'm on Earth. All right? My mass, let's say that my mass is we can call it M1 or M2. It's really up to you. I don't prefer numbers. I prefer letters as subscripts. That way I can kind of make sure I'm using the right number or using the right variable. So I'm going to call M1 the mass of the Earth instead of M1. And M2 I'm going to call the mass of the person or me. That way I know what I'm talking about. So when I think about the net force, the mass times acceleration, I'm thinking about the acceleration not of the Earth, but of the person on the Earth. So I'm going to go ahead and make sure that I label that MP. Okay? So now I'm left with this expression, Mama G ME times MP over R squared. Now R squared is the distance between the center of the Earth to the person. It's effectively the radius of the Earth. Let's start doing some things. I noticed that there's a mass. The mass of the person is the same on both sides of that equation. I'm going to drop that out. So now I'm left with Mama G times the mass of the Earth times the radius of the Earth squared is equal to the acceleration of an object, or the acceleration of this person. All right, let's think, folks. Is Mama G a constant variable? Does Mama G change? No, it's the universal gravitational constant. That's not going to change. That's a constant. It's even on my constants page. Does the mass of the Earth change? It's not on my constants page. But come on. Does the mass of the Earth change? Generally speaking, no. No. This is also a constant. How about the radius of the Earth? Is the Earth getting bigger or smaller to a great degree? No! This number right here is a constant value. If you plug in Mama G, you plug in the mass of the Earth, you plug in the radius of the Earth and square it, do all of your algebra, guess what number you end up with? Holy smokes, folks, you end up with 9.8 meters per second squared. This is the acceleration due to gravity on our planet Earth. We end up calling that baby G. We also call that our gravitational field strength. It is the strength of the gravitational field on this planet. So I guess we kind of have a new equation, right? Not really, but we have the strength of our field on any planet, the strength of the field is equal to the universal gravitational constant times the mass of the planet or object that you're on. Maybe it's not a planet, maybe it's a star, maybe it's a moon, divided by the radius squared of the planet. And this equals G of that planet. So it's not G. Maybe G is reserved for Earth. We're earthocentric here in physics. But G of that planet. It's the field strength of that planet when I use Mama G, mass of the planet, divided by R squared of the planet. Remember, in Unit 1, we talked about how objects fall at the same rate regardless of their mass. Regardless of their mass, objects have the same acceleration. We can prove that through Newton's universal law of gravitation. Now, number 7 on our worksheet number 5 is a great example of us trying to use the gravitational field strength or using this version of Newton's universal law of gravitation to do a little math. So try to do number 7 after watching this video. I hope you better understand the differences between Mama G, Baby G, and I hope you understand where we get 9.8 from. That's all I got for you. See ya!